Okay, this is Logix Designer, which is Studio 5000, which is the little icon at the bottom of the screen. When you open one of those programs, it looks like this when it's open down at the bottom. RS Logix has gone through multiple stages, and the latest stage is what we call tag based. So in the Click software, you had the address picker. You could go in and you could put in nicknames and everything else. And your memory is basically organized. You knew what you could use and what you couldn't use. In Allen Bradley, it's what we call tag based. And so the tags are created as you need them. And so the different tag types are available as you need them. Okay, tags are two types. There are controller tags that are for the whole controller, and then there are parameter and local tags that are for the program in the controller. Now, if your controllers are going to share tags, then you need to make them or if you're going to have the same program in multiple PLCs, you want to use parameters and local tags, and that way your programs will all look alike. If your controllers are going to share tags, say one across the network to another, then it needs to be in the controller tags. That's the easiest way I know to explain it. So if I look at the local tags, and I would also say in I would also say with this software, it's click and wait on these computers. I don't have a whole lot in the local tags. I think I put everything in controller tags. So let's look at that one. There they are. So basically I created, and some people go in and they'll create arrays just so they have tags. So if you needed Boolean, there's 32 Boolean points that I can use in this array, and I can extend it down. And so this would be exactly like what you would see in the older Allen Bradley or the address picker. I've just got some Boolean points that I can use. This is okay if you know what you're going to do and you're going to be consistent. Here's some integers, and this is a double array. It's actually 2 by 8. So there's 24, right? 0 to 2, 0 to, I guess 0 to 9. So it goes 0 to 7 and then 0 to 2. Or does it go 0 to 2? Nope, 1 to, okay, 1, 7. So 2's the limit, 8's the limit. So it's 0 to 2, 2 by 8. So there's 16 places in there, and you can put a different integer in each place. So you can create these very easily. And then if you expand one out, each integer then has 16 Boolean points that you can make ones and zeros. So you can use that if you'd like to, set up stuff ahead of time. Probably what's going to happen is you're going to create the tags on the fly. So on the fly, you can go in and you can just call something B10. So this is a 1 point. You made it a Boolean. For a stoplight, left green, left red, left yellow. These are just Boolean points. They're going to be points in memory. So instead of having like an address picker and going in and labeling what everything is, you start with a label, and then the software sort of, and then you tell it the data type, and then the software sort of keeps track of it. Now these grayed out ones are the actual cards. So this is local 1, which would be slot 1, local 2, slot 2, inputs, outputs. That we have to look over here. So here I've got my processor in slot 0, and that's the 1756L81. And this is the new processor with the stoplight. My first card is an input card. It's got 16 AC inputs. And so I can actually break these down into the I and the C. I'm not sure what the C is. The C, I think, has to do with status. Filter off and on. So there's different things you can do with the inputs. But you can have local 1 fault data, but then your actual points that you would use wiring in come in as local 1 I for input data. And what you see is that you've got your 16 points here. So those are your 16 wired points. So it's local, slot 1, I for input, and then the data is the actual data point. Now there are some other tags that are used by default, and therefore this is what I do if there's a fault, or I'm not 100% sure. I haven't used that a lot. This was all stuff that was added with the newer software. So for local 2, I've got I and out. So I've got my input data, which is kind of weird. I got input coming from an output. And then I've got my output data, which is my output, 16 points. So these are my hardwired 16 points. Now I can go in and take and put, just like we did an address picker, I can put an alias and a description for each of my outputs to what they're physically wired to. So I can do that. So what I would suggest is you do your local I input data, I data, your output data. What other cards do I have here? So I was trying to get it up there. All right, card 3 is an analog input card. Card 4, or slot 4, starts at 0. Slot 4 is an analog output card. Slot 5 is an Ethernet card. So my analog output card, there is my channel 0 data, channel 1 data, and I don't know how that's configured. It's probably 8 or 16. So when you actually set up the card, you configure it. Just like in the click, you come into the back plane and then you've got to add these cards. So the way you would do that is click on the back plane, because it should show up once you select the right PLC. And if you right mouse click, you can import modules. You can put in new modules. So when you put in a new module, you tell it it's slot, and you can import a module. The older compact Logix PLCs I have, Discover modules don't work. And Discover modules actually do work with the newest PLC or the latest Allen Bradley software, but you have to be online. So if you're online and you don't want to go in and put in each of these individually, you can go in there and let it discover what modules it has. So a little bit of setup. So my input card, if I look at its properties, then here's my general properties for my input card. I think this was supposed to be newest. So it's a 1756A10 chassis. Here is my, oh, this is my actual processor. If I do select the wrong processor, I can change it. And I can go in and set up its internet protocol if I would like if it's got the Ethernet address port configuration. Security, you just got a lot. Now, if you want to know what each of these things do, you can certainly go in the manual and read on them. But when you're just programming, generally you can get by with the defaults. So let's go to an input card. Look at its properties. And we wait. The circle means wait. Ta-da! So I can actually change it to the card I want. I can actually change the slot number. Now, one of the things that is very important is your module definition. So you're going to have to set, when you add these, the revision number and the port number. Now, the nice thing is, if you're online and you're setting it up, you can actually go online to the module and it will come back from the module, all the information here. And then you can go into the general tab and you can make whatever you want. So revision is very important. 3.002 happens to be the revision for that input card. There are other revisions that you can do. If you don't set up your inputs and outputs right, what you will see is a little yellow triangle there with a warning, and that usually means you have a revision mismatch. And whenever you have a revision mismatch, you could have some strange things happening. So you got to make sure everything is configured right. Analog input card properties. It's got 4 channels set up. There, it's got a little bit different revision. Its input is differential, so it's actually comparing between 2 wires coming in, which is not what we normally do. We normally set that up to be a single-ended, in which case we would wind up with 8 inputs compared to a common. And analog output properties. This has 8 outputs. And I think you can go in, yeah. And this is where you set up your output card. So you're going from 0 to 20 milliamps, and you can change that. If you're setting it up, you can make that 0 to 100%. You can actually change this to match your range. So you can set your milliamp range to match the range of whatever you want to read. And that way you get your engineering units out, and you can go in there and do a lot of configuration on your analog output card. Again, when you're just now starting with this stuff, stay pretty simple, stay pretty much with the defaults. It's just easier that way. And of course, I'm going to click OK for all that stuff. Now, what does a program look like? There's a program, main routine. And that's a retentive timer. So in Click, we made the timer retentive. I forgot what we had to set. Alan Bradley actually has a retentive timer. Here's my local 1, I, data 0. So this would be a switch coming in on slot 1 as an input to the 0 or the first connection. So that's probably where I've got my start buttons hardwired. This is my stop button. Nope, that's my stop button. This is my start button, and then this would be an output to one of the lights. And so I've got a timer. I've got subroutines. They're not blue like they are in Click. And so this is where I've got my selector switch, stop PBs. And in the tags, you can go in and you can say, oh, I want to call stop PB. and it's actually a Boolean, and this is what I want it to do. Something else that you can do in the Allen Bradley that you can't do in Click is you can actually line up all your outputs. So if you want to turn on your left yellow and your right yellow, you can just put them in order. Older PLCs, you're only talking one output at a time. Newer PLCs, particularly Allen Bradley, you can make one line programs. So you can have input, output, input, output, input, output. So as long as you want to go. I don't know why you do that other than you can and you want to play with it a little bit. But yeah, you can make some changes. And I don't remember what's in here. Okay. Selector, start, stop. And I don't think this is an active program. But this is what the PLC looks like. Now, if I want to change things or add things, if I go into favorites, this adds a rung, shortcut for adding a rung. There's more than one way to do it. This adds the branch, and Click, it was control arrow down. So this adds a branch. They almost never go where you want them, but you can move the ends around. This adds this allows you to add a multiple layer branch. I haven't used that one a lot. There's your examine on, your examine off contact, your regular output, your unlatch, and your latch. Now in Click, it was set reset. In Allen Bradley, it's latch and unlatch. Okay, so that's in your favorites tab, which is always on the far left. And then add-ons, alarms, bits, and what you see when you get to the bit tab, if it'll go there, is I get a lot of what I had. But you also get the one-shots. These are your one-shots. You got a timer counter tab for your 3 different types of timers. So you got timer on, timer off, and then the retentive. Timer on, and then there's your counter up, counter down, and your reset for the counters. Input and output, I think these are immediate inputs and outputs. Immediate output, message, get system value. Compare, there's your greater than or equal to, less than, equal to, all that. Move logical, move. That one is a very powerful command because you can actually move. PLCs are nothing but numbers. So I can take numbers from one part of my program and I can move it to the another part. And you might think, well, that's trivial. Well, if where I'm moving it is an output, then that's going to affect my lights. So I can have different moves in there to move from different memory locations to the same memory location and actually control my outputs. And that's more of an advanced concept. And I think I've got one in there somewhere. This is a mass move, so I can move, instead of moving all 16 bits, I can choose which ones I move. You got and or. Exclusive or, so you sort of got gates in your ladder logic. And the nice thing is that tab does not end. So compute and math, there is your math functions. File miscellaneous. I don't think I've done a lot with that. There's a file copy. That's not the same as the copy in the Click. The copy in the Click's more of a move. File fill. File shift, there is your sequencer tab, sequencer input, sequencer output, and sequencer load. So I think you can actually load sequencers out of memory. Equipment phase, program control. That's one we need also. So we got the jump subroutine, return, labels, I think if you jump to a subroutine, it's looking for a label, or no, jump goes to a label, jump to subroutine goes to a different program. Again, you've just got a heck of a lot of options. Special HMI, there's the special. There's a PID function block that you can actually put in your PLC program. Now, I've seen that one not used correctly. And HMI button control. Trigonometry, sine, cosine, tangent. And now we're getting into advanced group of math. So it will do natural log and regular log. Well, that was advanced math. Don't let me go one more. There you go. Still not done. Math conversions. So you can go to BCD. From BCD, you can convert radians to degrees. Motion control. I mean, just, they made this software so you could do so much with it. And so, what was that? 3 lines that we went all the way through to get there. If we go back to the favorites tab, that's probably where you're going to start, and then maybe do a little more advanced. But you just got so much to do, or so much that you can do with this PLC. The other part of this I wanted to show you was the HMI. And I think, oh, I know I missed something. It's too much not to miss. So this is the program that brings up the PLC Studio 5000. This is the program that brings up the HMI. And so there's my HMI, and this is my toolbox, so where I can put in buttons, alarms, flags, everything. Common controls. And my panel 1, I can have different screens. In HMIs, Click, Allen Bradley, Siemens, they all do different screens. So do one screen to start with, and then maybe we can add screens. What I think would be neat is to have multiple screens, and each screen would be talking to a different PLC, so we can sort of monitor or run a program on a PLC from one screen, but do multiple PLCs. That would be a neat thing to do. This is one that when you select something, then you get its properties, when it will appear, position and size, security, if you're going to animate it or change the events. So you've got lots of different things over here, and it's, again, in the advanced class, you can't get to everything, but what you want to sort of see is get an overview of what's there, and then write a couple programs that, you know, will do some pretty simple stuff. I know what I missed over here in this program, but that's okay. So communications, I can download and upload project properties. I was looking for, how do I know how to communicate? And HMI to controller path. There you go. So for the HMI, what I've got set up is the controller, I think, is 2650. So if I know my controller IP address, then I can have my HMI go to that point or reference that across the internet. And that's kind of neat. And what else is there? Let's see, there should be tags in here somewhere. And I may have missed it. Project properties. Application references. No. Graphic Explorer. Name type. Animations events. Okay. So you can set your button behavior and then what you do with it. And I thought there was a way to set up tags. And maybe what I'm thinking of is the Allen Bradley stuff. I mean the click stuff. So start, appearance, position, size, security, animations, add an animation, don't care about that. Let's look at this one. Properties. There we go. Okay, so from a property standpoint, what it's doing is it's going to my PLC program across the internet. And it's pulling the newest counter to accumulated value. So what we did is we put counters in this program so that it would do a normal cycle for so many counts, then it would do blank cycle for so many counts, then go back to normal. So if you look at the PLC over there blinking, that's what it was doing. And this is the program for it. And that is where it was getting that. And I think there is a way to change it. Open expression editor. I don't remember. So that's a good, hopefully a little bit of a primer in terms of PLC HMI stuff. And thanks for watching.